Welcome, welcome. This video is going to be on doing min and max slope. As the assignment says, this version is from November of 2023. Might be a little different in future years, but should be the same basic idea. As the assignment says, we're going to practice creating minimum and maximum slopes on Google Sheets. Google Sheets was not designed to do this, so we're having to do a few workarounds to make this work. Not ideal, but we work with what we have. Unfortunately, most online graphing tools aren't really set up for kind of proper scientific analysis at this level. We use what we have, which is Google Sheets. If you forgot why we linearize, you can watch this video. So if you click on this link, it opens up a video related to the Gizmos lab we often do in the fall, really just looking at free fall. But the intro to this lab, we talked about doing minimum and maximum slopes and the purpose of like why we linearize and other things. So if you forgot why we're doing all of this and kind of the reason for it, then go ahead and rewatch that video just so you can get a sense of that. Now we're going to go ahead and get started. So you're going to want to open this tutorial video. Haven't posted the link yet because I'm making this right now. And the attached Google assignment, you can't quite see it on the screen yet because I haven't quite attached it yet, but it should be there by the time this actually goes live. Then you're going to open up that attached spreadsheet on the Google assignment. That attached spreadsheet should look something similar to this. However, this is a slightly modified version of it. I've made the what do you call it? The text a little bit bigger. Sorry, it's a little bit late. Text a little bit bigger, and a few other things just make it easier for viewing on the video. Yours will look a little bit smaller and kind of more streamlined. One thing to note is that at the bottom, there is some other stuff you need to do here, although it's not showing on the screen right now. When you first open it, it should be on resistor B. That's the one you're going to do solo. We are going to do resistor A together, so notice the two tabs at the bottom. So the purpose of this is to, again, plot our trend line and then plot a minimum and maximum slope. To give you a sense of what the experiment is, we're doing this for Ohm's Law with a resistor. We'll call it resistor A. It's an unknown resistor value set up in a simple circuit. A power supply is increased until the desired current is flowing, and then the voltage required is recorded. Here's an example with a simulation. So if you click on that, it looks kind of like this. So what you can imagine here is, for example, let's pretend we wanted to get a current of 10 milliamps. We would adjust our circuit or power supply until we got to 10 milliamps. That would be our independent variable. And then we would look at, okay, what was the voltage required to do that? In this case, it was 5 volts. And we would keep doing that for various currents. So here we're using current as our independent variable, even though we can't directly manipulate it. And the reason why is just because then slope will end up being resistant. So it'll be a little more clear later on what the meaning of everything is. So again, current is going to be treated as our independent variable. Voltage is going to be treated as our dependent variable. And so we're going to go ahead and get started. You'll notice, first of all, that we have data right here, but we also have this column for min and max. So first thing I want you to do is highlight all of our data, but also the min and max column, and then we're going to graph all of that. Now, I know there's not anything in those spots right now, but we'll explain why we're including those later. So I'm going to go ahead and go to Insert Chart. Now, sometimes it auto pops up with a column chart or something. Remember that we pretty much always use a scatter plot. We look at this and go, okay, cool. It's going up in a straight line, looks kind of proportional, kind of would expect that for a resistor following Ohm's Law. Awesome. Next, we are going to go over to Customize, and we'll go ahead and fit our trend line to it. So I'm going to go down here. I'm going to fit my trend line to it. I'm going to go ahead and tell it to use the equation so I can see the equation for that. I'm also going to take a look and see that it says my uncertainty is plus or minus 8 volts. That is a constant value, so I'm going to switch error bars on, and I'm going to go to constant, and I'm going to say 0.8. Up to this point, this should be review. So go ahead and pause the video, make sure that you can get to this point on the graph. Cool, welcome back. So in an ideal world, you would also go down and change your horizontal and vertical axes titles. I actually think I went to the wrong spot. Here we go, chart and axes titles. So you'd add in some titles and other things. Well, let's go ahead and do that just to be safe on things. Our horizontal axis was current and measured in amps. Our vertical axis was voltage measured in volts. Cool, so we've got that there, and our full title, we can say current or voltage versus current for resistor A. You can probably come up with a better title than that, but it's good enough for now. All right, so the main thing that we're going to actually care about is not just having a trend line here, like we see right there, but actually plotting in the minimum and maximum trend line. What I mean by that, remember, sorry, I'm having trouble grabbing it, there we go, is a trend line that goes through and is the steepest possible trend line that fits all of my data points, as well as the kind of flattest possible trend line that fits all of my data points. Whether that trend line is going up or down, just figure one that is a little bit steeper, one that is a little bit flatter. Now to do that, we're going to go ahead and insert some data points, and we're going to basically manually fit a new trend line to our graph. So let's start with the maximum. That is the one that is going to be the steepest in this case, and then we'll go with the minimum. So the maximum here is going to probably start down near the bottom of this error bar. So if you look at this error bar down here, we know that it goes plus or minus 0.8. So if this value is at 0.2, we can guess that this is down at probably a negative 0.6. And that's going to go up to somewhere around the 0.8 plus whatever this data point is. Now, it doesn't need to go to the exact top of this error bar. It really just needs to be the steepest trend line that fits all of the data points. Sometimes that's based on the first and last, or last and first data points. Sometimes it's like one of the data points on the middle that is the limiting factor, but again, the steepest and flattest that fit all of the data points or their error bars. So for that maximum, we're going to start down here at, what do we say, a 0.2 minus 0.8 gives me a negative 0.6. And you'll see that data point pop in there right around the, what do you call that thing? The bottom of the error bar. And then we're going to go to the top end. We'll add on to this data point. So this will be the 7.5 plus 0.8. That would be 8.3. 8.3. And we can see that data point go in there. Next, we want to add a trend line to it. So I'm going to go back into the series and edit. You can also go there from the triple dots. You can just go to edit chart. We're going to go to customize. We're going to go to series. Now here's the trick. Instead of saying apply to all series, I need to go and select maximum. And so I'll go ahead and change this. So I'm going to go down. I'm going to leave error bars off because I don't want to add error bars to my min and max slope. That would be weird. These are imaginary data points. So I'm just going to go ahead and insert the trend line, and I'm going to go ahead and turn the label to use equation. Now what this tells me is I can see the actual slope of my maximum trend line. Now let's go ahead and take a look at it here. Let me make it a little bit bigger for us. All right, let's go ahead and take a look at it. So we can see that's hitting all of the data points and their error bars. And, you know, it looks like it's about as steep as it can get while still hitting all the data points and their error bars. So we're going to go ahead and leave it at that. But for example, if, you know, maybe it was missing one of these data points, like maybe it was missing this one right here, what you would do is you would maybe bring up the bottom end a little. So instead of doing negative 0.6, I might do negative 0.55. And we can see that that data point shifted ever so slightly up, and so did the line. Or maybe you needed to do negative 0.3 or 4. Whatever you need to do to actually hit all of the data points and their error bars. And we can see that the slope adjusts a little bit while we're at it. So I'm going to take it back down to negative what do we say, 6. And that seems to still fit all my data. So now we're going to do that same thing with the minimum trend line. Let me shrink this back down a little bit just to get it out of the way. So we're going to do that same thing with the minimum trend line, but this time we're going to start at the top of this error bar and go to the bottom of this error bar. So if we're starting at the top, we're kind of adding the 0.8 to 0.2. So we'll start with a 1. We can see that data point go in. Notice that the colors switched. That's fine. It doesn't really matter, but I just want to call attention to that now we're working on red is the upper one and yellow is the bottom one. And then we go ahead and go all the way to the bottom of this error bar over here, which probably is 7.5 minus 0.8, which is, sorry, it's late, brain's not working, 6.7. There we go. Cool. Nope, typed the wrong thing. All right, so we got 6.7, and we can see those data points are in there as well. Interesting. Seem to switch. Okay, so it seems like our trend line switched over to our minimum. I don't quite know why that is. Probably because I did this one on the right first. Who knows? Never seen it do that before, but it doesn't really matter. We're still going to go through that same process of adding in a trend line for the other one. So whether it's your maximum or your minimum, just go ahead and go back to Edit Charts. You're going to go to Customize. You're going to go to Series. You need to change it to the series that doesn't have a trend line. In this case, we're going back to the maximum because the minimum stole its trend line. That was rude. Go ahead and click trend line. You scroll down again. You hit label and use equation, and now we've got two trend lines there. So if we take a look at our graph, and I'm just going to zoom in real fast. So if we take a look at our graph, we can see that we've got the kind of signature cross in those min and max trend lines. So that way we know that one is truly steeper and one is truly a little bit flatter. Remember that if you needed to adjust the trend lines a little bit, you might just adjust the point. Like maybe this one doesn't start at 1, maybe you needed to start it at 1.5 because it was a little bit higher. Or maybe you needed to start it back down at 0 because it was a little bit lower. Like whatever you need to do to adjust it. Honestly, if they had a program where you could just draw the line in and it would tell you the equation, we would use that. Well, they do, but if we had it for free, I should say. So that's what we're going to do. Now, let's talk about a few formatting things. Notice that we've got these imaginary data points that are still left on our graph. Those aren't real data points, so we don't want them on there because people might look at them and be like, oh, you collected weird data points at the top and bottom of your error bars. Why did you do that? We want to get rid of those data points. So to do that, we're going to go in here to the Edit Chart. We'll go into Customize and Series one more time. And here where it says the point size, instead of applying to all, we'll go over here to minimum. And where it says the point size, instead of 7, we'll say none. And notice that that data point now disappears. And so we just have the line, which is all we really wanted. We're going to do the same thing with the maximum. We're going to then go to the point size. We change it to none. And then that way, again, we only have the trend lines on there. We don't have the random imaginary data points that we were using to guide our trend lines. Notice over here on the right-hand side, we have our original slope, we have our minimum slope, and we have our maximum slope. So we can use those two, using max minus min over 2, to figure out the uncertainty in the slope. Other things to note, oh, it looks like this red one actually is missing this error bar, so I actually do need to adjust it. Let's see if I can fix that. We need to bring it down a little bit, so I'm going to bring it down to about 0.8. Yep, there we go. So it looks like it's now hitting that one. Let's do a quick double check I didn't miss. This one looks like it's getting missed a little bit, so I'm going to bring up the bottom end a little bit. Maybe instead of 6.7, we'll do 6.8. If we tweak it just a little bit, yep, that looks like now it's hitting that data point right there a little bit better. So again, notice that we're not always going to the exact bottom of the min and max error bars, or sorry, of the error bars on the first and last data points. Sometimes we have to adjust it a little bit just to fit our data. Now, another trick for formatting is sometimes it's a little weird to have all of this space over here as just your trend line information. You can always double click on the graph. Here we go. If I click on the graph space, usually that's where I could edit it, but maybe, here we go. Resize chart area. Nope. they've changed. Here we go. I just have to have it already open. So if I click on the kind of chart area while I'm doing this, if I click on the white space, we can see the little resize buttons. And so if you want to, you can kind of make this bigger or smaller. The other alternative is you can go to your legend, and instead of having the legend position be auto, you can tell it to just go up top. I often like to put it there instead, because now I can take this graph and I can make it a little bit bigger, and I can make the font size bigger. So instead of auto font size, maybe I'll choose a size 20, and I might do the same for the font size down here just to format things and things like that. But those are some little pro tips just to make it a little bit easier in formatting. But the main idea is that you are plotting your minimum and maximum slope. All right, now that we've plotted our minimum and maximum slope, let's go ahead and figure out our uncertainty. So our maximum slope, it's asking just for the equation and results. It looks like for my trend line, my slope or my equation was 7.72 times x. So down here, I'm going to say, instead of saying y equals 7.72 times x, and then we had a y-intercept of plus 0.05. So instead of using y and x, I always want to use my actual variables. So in this case, I'm going to use I because that's my current, and I'm going to use V because that's my voltage, so that I actually have the proper trend line. Now for my maximum slope, it looks like if I scroll up, my maximum slope was 8.9, my minimum slope was an even 6. Wow, that's random. So we've got 8.9 for my maximum slope. My minimum slope was an even 6. And for my uncertainty and slope, remember it's max minus min over 2. So I can just say equals, and I'll put it in parentheses, maximum minus minimum, close parentheses, divide by 2. And that gives me my uncertainty of slope of 1.45. So what that really means is this slope, or this equation right here, of I equals 7.72 times V, nope, I put that backwards, catching that now, V equals 7.72 times I, there we go. When we've got that V equals 7.72 times I, what this really means is that we know this slope of 7.72 to give or take 1 point, probably reduce a decimal on that, give or take 1.5. So I probably should even reduce this to just 7.7 so that we've got even decimal places across the board. Bump that up. Cool. So really what we know is that the slope of our trend line, or the coefficient, is 7.7 plus or minus 1.5 here. Now if we look at our slope, we can see that slope is rise over run. So rise over run is going to be a voltage divided by a current. Remember that voltage over current is just resistance. So really what this slope is telling us in this case is just our resistance. That is that, well, it's just by definition the resistance. So that means that our resistance here, I can put it on the side, resistance for this unknown resistor is going to equal 7.7 ohms plus or minus 1.5 ohms. And so we can actually report this out as our kind of official results. Let me make that a little bit bigger for you so you can see it. 18 on the fonts. Cool. So our resistance would be 7.7 ohms plus or minus 1.5 ohms. Somehow the 1.5 got clipped off, but you got the idea. Plus or minus 1.5. So if we wanted to report this out for one reason or another, we know how well we know this resistance. What you're going to do now is go over to resistor B, and you're going to do this on your own. So same process that we just did for that resistor A. I'll fix that label up top. And then don't forget to put the equation, the max, the min slope, and the uncertainty and slope, just so that you have it. When you're done, don't forget to submit. That's all.